Okay. Good morning. Sorry, I was thinking that our session start was 10:15, but actually it's a start from 10 o'clock. So welcome to the Stockpile Management session. There is a Lidberg switch, room switch. If you are coming for the getting scanning on the skin hairs research, you need to move to, welcome you to stay, but otherwise you might have to move to the B3, room B3. So I'm going to, basically, my name is Guangwei Huang, Associate Director of Food Research and Technology at the Almond Board. I oversee a managing research project in food safety, almond quality, biomass utilization, and alternative harvesting techniques. So our session today is about the stockpile. Stockpile management is critical to food safety and then almond quality. Proper stockpiling management begins with adequate dry fuel run and site preparation, proper tarp use, and close monitoring of moisture, and so on. So the stockpile is a common storage practice for holler-sholler to restore fuel run almonds, and many are very experienced. I know all of you, quite experienced stockpiling management. But, as the industry continue growing, the bearing acreage continue to grow, and at the same time, the number of hauling shoring facilities remained the same for last several years. So there is definitely the need some changes. Maybe we need to store longer, or maybe store at the grower side. So this is add some uncertainties. So this is needed attention. So we need to refresh our knowledge, industrial knowledge about the stockpile management. So essence of stockpile management, it is really management of moisture or humidity. That's going to begin with the growers at the orchard side on the timing of tree shaking or drying on the floor, or the time to pick up. Then carries through by the holler-sholler with the close monitoring at on the stockpiling side. So it's really an elevated moisture will cause some concern, increase the food risk, such as including increase the mold growth, aflatoxin genesis, or the pathogen increase. So this is, and also quality deterioration, such as a cancer damage or loss of a product. So this is very critical to our industry. So in this session, we will have two research speakers going to present their research findings, and followed by our one industry member speaker shared some practical tips on the stockpile management. So now I'm going to introduce our three speakers together. I'm going to have them to speak, and then followed by a short panel discussion and Q&A. So first speaker is Dr. Bruce Lamplin, and a professor of cooperative extension at the Department of Plant Science at UC Davis. His research focus including the plant-water relation, canopy development in tree crops, have done some look at the impact of deficit irrigation, pruning, nutrition on the canopy development and yield potentials. So today he will present their research findings on the almond drying in orchard and moisture management in stockpile. And the second speaker is Dr. Seamus McLeodis. Dr. McLeodis is a plant pathologist from Kearney Agricultural Research Extension Center and a lecturer from Department of Plant Science at UC Davis. His research focus including ecology and ecology, epidemiology, and then prediction and integrate management of above-ground fungal diseases and post-harvest diseases of tree fruit, nut crop, and vines. And he also have looked at the post-harvest aflatoxin, ochratoxin contamination. So today, he will share their research finding on the aflatoxin contamination in almond production. Our last but not least speaker is our renowned industry member, and Mr. Brad Craven. Brad is the from Minter Honing Cooperative, Brad has had a long career in crop processing, first in cotton gin management, and then finally as a member of almond honing operations. During his career, he served several terms as a director and chairman for the Almond Alliance of California. He has also participated on several committees for Almond Board of California, including serving as the chairman for the Organic Advisory Panel. Since retirement in 2018, he has had opportunity for long-term consulting for several almond operations, including a 2018 long-term commitment big commitment in Australia, and most recently as an interim manager for Minter Honing Cooperative in Chowchilla, California. Sorry, I had to pour Brad out of his retirement. So had to, his knowledge cannot get lost. We had to have him to share his knowledge with wisdom to the industry. So now, welcome, Bruce. Thank you.
Thanks, Kwang Wei. Yeah, so I'm going to talk about our work on stockpile management. This work was done in cooperation with famous Mcpc and a number of other people. We worked mainly in Kern County and San Joaquin County, most of our stockpiling. We did a little bit in the northern Sacramento Valley as well. And first I'm going to talk a little bit about how the orchard microclimate influences the food safety risk, and looking at our work on midday canopy light interception versus orchard floor temperature and how that relates to food safety. Then nut drying on the orchard floor, if they're left in place versus conditioned in windrow. Row orientation for hedgerows, if they're north-south versus east-west facing. And then I'm going to talk about the different types of tarps for stockpiling, clear, white, and white on black. The stockpile orientation and north-south versus east-west facing, and then how we measure moisture content. And this is our light bar that we developed about 10 years or so ago for measuring light interception in orchards. What we do is we drive this through the orchard and we can measure the level of light interception. The image on the right shows the pattern. We can actually mark every plot. So this is a trial that has research plots. And when we get done, it plots this out on Google Earth. And this just shows some of the temperature data that we've collected with this device. And basically, it's just showing that if you look at where the Y is on the upper graph there, that's where it's totally sunny, so there's no PAR interception, and you can see the temperature goes way up there if you look on the bottom graph. And so the temperature is directly related to how much sun is hitting the orchard floor. But there's also an effect of the canopy density as well as the canopy size. And if you see the upper right-hand image shows a mechanically hedged orchard. It has a very dense canopy. You can see underneath there's very heavy shade on the ground. And then the orchard floor temperatures are cooler under these situations versus in the bottom where you have an unpruned or a hand-pruned, much more sparse canopy where you have more light coming down through the canopy. So there can be a big difference in terms of how much light is coming through the canopy as well as how much light is falling in the middle of the orchard floor. This just shows a hedgerow and a more traditional spacing with hand pruning. And this is what happens sometimes when you have these really cool conditions under a tree canopy in a dense mechanically hedged plant. You can get a lot of growth of things underneath there. And we did a thermal imaging of these orchard floor temperatures with a FLIR thermal imaging camera. And this is what we found is that you can get temperatures up to 163 degrees Fahrenheit in the middle of these rows where the sun is hitting. And then underneath the tree canopy, the temperatures are in the range of 80 degrees Fahrenheit. And this is the ideal temperature for salmonella to thrive. And this graph on the top, the red dots show the center of the drive row temperatures. And on the bottom axis, as you're increasing in light interception, so on the bottom axis, if you get above about 70% or so light interception, the temperatures start dropping off in the middle of the drive row, and you can see that hatched area on the bottom is the ideal temperature for salmonella. So as you get above about 90% or so light interception, you have some really ideal temperatures on the orchard floor for salmonella and other microorganisms. And basically, we found that you can produce about 50 kernel pounds per per 1% light intercepted. So you can produce about 3,500 kernel pounds at 70% interception. So if you're producing more than 3,500 kernel pounds, you really have to start paying more attention to your food safety risk. This is one of the orchards we worked in this trial that was at 92% interception, produced 4,600 kernel pounds per acre. And this is definitely where you're going to have a lot of risk for food safety problems potentially. Now, we also did some studies where on the left-hand side where we shook the trees. This was in an orchard near Woodland in Yolo County. And then we just measured at the end of the drying period, just before they were going to, in this case, the grower shook the nuts, just left them in place on the orchard floor to dry, and then swept them just before he was going to pick them up. So we sampled the nuts in the different positions in the orchard just before he picked them up. And what we found is that there was about 2% wetter nuts underneath the tree than in the middle of the drive row when they just left them to dry like that underneath the trees in the place where they fell when they shook them. And on the right-hand side, this orchard was windrowed, and then they were left to dry in the windrow. So as soon as they were shaken, they were windrowed. And we found, again, about 2% difference in the moisture content from the top of the windrow to the bottom of the windrow. So it's wetter at the bottom. So this is ideally, if you're going to do that, if you're going to windrow them and let them dry in the middle, it's much better if you can condition them. These nuts in the lower right-hand side will run through a conditioner to blow the leaves out and to spread them in a nice even layer, a much thinner layer, so you get much more uniform drying with this method. I think there are several machines for doing the conditioning in the exhibit downstairs. And the nut drying really varies a lot depending on the canopy size, so it's really important to sample across the gradients in size. This shows an orchard in Woodland where we sampled, and you can see in the areas where it was about 75% light interception, the nuts were quite a bit wetter. The relative humidity is the humidity around a container of nuts. I'll talk about a little bit later, but basically there was about 2% or so, or 3% difference in moisture content across that orchard depending on the level of light interception in the different areas. And this is just data from a bunch of orchards that we looked at, and the blue box is basically the range where you want to be, and the ones underneath that line are too dry, and the ones above it are too wet. Now, it's not really too much of a problem if you're going to stockpile if they're too dry, because they will equilibrate to the ambient humidity over time in the stockpile. But you definitely don't want to be on the too wet end of things. And in this case, you can see on the orchard on the upper half of this photo, it's very uniform. And in that case, the drying is pretty uniform. But in the bottom where you have a lot of missing trees and variable canopy, there's much more variability in the drying potential when you put the nuts on the orchard floor. So you really have to do more sampling of nuts before you pick up if you have a more variable orchard like that. The other big factor is the orientation of hedgerows. In this case, this grower had the same exact planting on a north-south hedgerow versus an east-west. And we worked in here looking at the temperatures and the quality. I should also mention that the north or the east-west oriented hedgerow actually harvests about 7 to 10 days later because it takes that much longer to dry the nuts in the fall because of the angle of the sun. And this just shows a picture in August of what happens with the light interception in the left and the east-west facing hedgerow over the course of the day. You can see the middle of the row gets a really nice direct sunlight in the east-west row. The north-south is much more speckled, but you have light going across the whole orchard floor in the north-south hedgerow, whereas the east-west, it pretty much stays in the shade underneath the tree row over the course of the day. So you have much more ideal conditions in this east-west row hedgerow for a salmonella to thrive and other microorganisms to thrive underneath that tree canopy. Whereas the one on the right, you can see the sun sweeps all the way across the orchard floor over the course of the day. So the north-south oriented hedgerows have a much better light distribution over the course of the day, and it can be very difficult to dry nuts in the east-west oriented rows, especially for the late variety, because as the sun angle changes for the later varieties, sometimes you get almost no sun on the orchard floor on these east-west hedgerows once they're mature. I'm going to talk a little bit about water activity. This is the way water activity is what determines the ability for microorganisms to grow on the food materials, and that's what it's important rather than the water content. So ideally it's better to measure the water activity, and a water activity of less than 0.6 is best, and that's a relative humidity of 60%. So what we did is we took samples from the orchard floor, put them into these plastic containers, brought them to a constant room temperature, and then measured the humidity above those samples. And if it's less than 60, that means it's an ideal humidity for stockpiling. And it's also important to realize that the difference at a given water activity, the hulls have much more moisture than the nuts with hulls or the kernels. And so you have to differentiate those things. If you're measuring the kernels individually, it's a different relationship. This table shows the three right-hand columns. The third from the right shows the kernel and the hull water content at a given humidity, and then the hulls and then the kernels on the right. So it's important to remember that there's a difference in the hull versus the kernel moisture content at a given water activity. So you really want to sample across the range in gradients and shading across your orchard, and make sure you get the areas that are the most shaded and the least shaded. Then next I'm going to talk about our work with stockpile different tarp materials. We used either white on black tarps and white tarps or clear tarps. At the time this work was done, most of the tarps were clear. And this was a big project. We put these sensors all the way through the stockpiles as they were being formed. So we put them in at 3 to 4 different heights in the stockpile. It was very difficult to keep relative humidity sensors operating in these dusty stockpiles, so we didn't get a lot of good relative humidity data. And the sensors were approximately in the middle of a long stockpile on a north-south facing oriented stockpile. They were about in the middle of that pile. And this shows the temperature in these stockpiles in Kern County. The ambient temperature is the purple in the bottom. You can see it's ranging from about, this is in degrees centigrade, sorry. Degrees centigrade from about 20 to 40. And then the white tarp is slightly warmer than that. The white on black tarp, you can see the green lines is just barely warmer than the ambient temperature. But the clear tarp has much bigger temperature swings from day to night. And this is what causes problems, is these big temperature swings cause water to condense. And this shows the black line shows the ambient, the white line shows the ambient. It's kind of hard to see that on this graph down at the bottom. And then the clear tarp is the blue, and again, you can see the fluctuations are much bigger than that than on the white on black tarp. And these tarps are up to 40 degrees Fahrenheit cooler, or the stockpiles underneath these white on black tarps compared to the clear tarps. And this is what happens over the course of the season. The top 3 lines are the clear tarp, and you can see at the top and 3 feet down and on the side of the pile, in all cases over the storage period, the moisture content increased in all these positions. And on the white on black tarp at the bottom, it was much less of an increase in moisture content over the storage period. So plus 5% higher moisture content in the top of the white on black pile versus the 27% increase in the clear tarp. And this again shows the temperature fluctuations on the left-hand side is the dry clear stockpile, and then on the right-hand side is the white on black stockpile. And this shows what happened when we opened up these tarps. On the left-hand side is the north end of a clear tarp. You can see there's a lot of growth of microorganisms in the top of that pile where the water has condensed against the plastic and then wet the nuts. And on the right, you can see the white on black tarp has very little or almost no problems with the condensation and growth. And this shows a clear tarp. In this case, this was stockpiled since August, so we left this in as long as possible. This was the first stockpile put in and the last one taken out from this operation. And you can see there's a lot of growth on this clear tarp versus the white on black tarp by the end of this storage period. And one of the other things we observed is that if you take these ridges out from when they're forming the stockpile, they move it forward about 30 feet or so and put another pile, and you end up with these humps. And where those humps are, you get a In between those, you get a depression and the water condenses and runs down and then collects in those valleys in the stockpile. So if you can flatten out the tarp, you have much less problems with this condensation in these low spots in the pile. It's also much better to have the long axis north-south, similar to the orientation of the orchard for the hedgerows as well. You get a much less mold growth potential if you have a north-south facing long axis. So these are sort of the general guidelines. Don't stockpile if either the hull moisture content exceeds 13% or the kernel moisture content exceeds 6%. And this is equivalent to a water activity of 0.6 or a relative humidity in these containers of 60%. And then the hull moisture content, 11 to 12% is acceptable, and this is pretty much when the hull snaps. It's what growers frequently use to decide when they're dry enough. If they're greater than 13%, they tend to be much more flexible, and this is too wet. And then the kernel moisture content, 4 to 5% is excellent. Less than 6% is okay, and greater than 6% is too high for stockpiling. So the food safety risk should be assessed in relation to orchard planting design and canopy structure. And the more uniform the orchard canopy development is, it leads to more uniform nut drying on the orchard floor. So all the way from the beginning of planting the orchard, if you keep this in mind, and if you can keep the trees growing more uniformly, if you get a lot of variation in tree size, it creates a lot of problems down the road. The hedgerow plantings tend to lead to more dense shade underneath the tree, which may increase food risk, safety risk. And this has to do with the fact that every time you mechanically hedge, you generate 2 or 3 shoots, and you get this denser and denser outer canopy where you have that hedging cut, and that makes a really intense shading, tends to shade out the lower part of the tree, but it also creates these temperature problems on the orchard floor. And as I mentioned earlier, north-south oriented rows, especially if you have hedgerow plantings, are better than east-west plantings. And anytime you have an orchard producing over about 3,500 kernel pounds per acre, that's about 70% interception you need to produce that, you likely have increased food safety risk related problems. Now, in terms of stockpiling, the sample nut moisture content should be sampled in a systematic way across the orchard before beginning harvest. You really need to sample all the way across the gradient. What we usually do is look at recent Google Earth image of the orchard and sample across the gradient from the area that has the lowest light interception to the areas that have the highest. And make sure that the nuts are adequately dry before stockpiling and have a water activity less than 0.6. And choose appropriate tarp materials to minimize condensation potential. White on black has performed the best in our studies. White is better than clear, and clear is the worst. And then orient the stockpiles with the long axis facing north-south. I think that's all I have. I don't know if we're going to do questions now or after.
Can we hold your question until we get to a Q&A session? Unless you have a very burning question, we can have one. Let's do it. Maybe too late.
Okay. Good morning, everyone. Guan Wei, thank you for the introduction. My talk will be on aflatoxin management in almond production. For this, there are several people involved in this research, and the main player is Ramon Jaime, who is in the audience, and also another person, a postdoc, who joined us. Pami is not listed there. But we have people from our laboratory and also people even from the University of researchers from the University of Cordoba in Spain. So what is aflatoxin? Aflatoxin is a compound, we call it secondary metabolites, compounds produced by these two fungi, the Aspergillus flavus and Aspergillus parasiticus, and these, which live in our orchards, and these compounds, the aflatoxin or better aflatoxins, because there is a group of aflatoxins these fungi produce, they are very toxic, carcinogenic, and because of this toxicity, the various governments regulate them strictly. And here's an example. In the United States, the regulatory limits, the tolerance is 20 parts per billion for all the aflatoxins. And for pistachios and almonds for direct consumption, the European Union is very strict with 8 parts per billion for the B1 and 10 parts per billion for all the aflatoxins. And other dry fruit and let's say and walnuts, these regulatory limits are even lower. Now, we export a lot of almonds in Europe, and most of you probably have heard about the rapid alerts. When a load is, when the aflatoxin or mycotoxins are detected in loads of not only almonds, but any other crops, they will issue a rapid alert. And here we have an example of 5 years of rapid alerts, and you can see from this graph that the aflatoxin is the top mycotoxin that is found in the various crops, followed by ochratoxin, and then the various other mycotoxins. And because almonds also get rapid alerts in some years, a high number, particularly in years when we have very high navel orangeworm damage, the almond industry has taken measures to really support research, support it, and also supporting now research to control the aflatoxin and to follow the, to come in compliance with the regulations and the tolerances that are imposed by various governments. Now, these fungi, the Aspergillus flavus and Aspergillus parasiticus, live in the orchards, in the soil, and they produce those black structures, so that we call them sclerotia. This is the way they survive. And also they multiply in debris of the orchard. And these debris, they'll produce spores of these fungi that become airborne and reach the canopy, where they will infect the nuts. And particularly if you have navel orangeworm, the damage to those kernels will get direct infection by these fungi. At the end of the season, after you harvest the crop, there will be some mummies left, and we know now from research that depending on the variety, 2 to 10% of these mummies will be infected by Aspergillus flavus and parasiticus. So, as you can see, the navel orangeworm is a main player for aflatoxin contamination. We did a study with the USDA in Albany, and we showed that when we increase the feeding sites or the wounds of kernel by the navel orangeworm, the aflatoxin amounts increase. This is a study in the laboratory. But we also have results from studies with real-time samples, and in this case where we classify these nuts in different damage levels, you can see that the ones that they have more than 2% of navel orangeworm have the highest frequency of positives and the highest amounts of aflatoxin. So the navel orangeworm not only causes the wounds for infection, but also we found out here that when we analyze some of these moths that come out from the mummies, we see that even in March, April, the first emerged navel orangeworm, they're contaminated with Aspergillus flavus and parasiticus. And later on, moths that we trapped from the following flights during the season, this incidence of these fungi on the moths is really high. So you can see that the mummies will provide the navel orangeworm to start the cycle of the life cycle, and also creates the wounds for infection and brings also the pathogen in addition to the wounds. So here's an example when we examine mummies of almonds. Depending on the variety, we found 2 to 10% of these mummies infected with Aspergillus flavus and parasiticus. And then when we recorded the moths that emerged from these mummies from 3 orchards, you can see the high levels of Aspergillus flavus and parasiticus occurring on these moths. From 50 almost to 75% of the moths will have the propagules of these fungi. So you can see from this slide that how important is the sanitation and how important is the removal of these mummies from the orchards. So one thing, if you don't do sanitation and you leave mummies on the trees, and some of these mummies will be shaken during the current harvest, you'll have a mix of some mummies from the previous years. So we want to see what is the fate if those mummies, the kernels from these mummies, contribute to the aflatoxin contamination. And in this case, we did some limited samples. We analyzed them for aflatoxin, and we did not find aflatoxin, but we're not sure still, because these studies have to be done in more samples in order to make a definite conclusion if the kernels from the mummies that are mixed with the current crop contribute to aflatoxin contamination, especially now. Because of the drought, some of these mummies will be very intact and they don't decay, and some of the kernels will be very similar in appearance with the current nut kernels. So one way to reduce aflatoxins, and I emphasize again sanitation, and the other way is to attack really the pathogen. And in most cases, in controlling diseases, we attack the pathogens or making the plant to be protected by the pathogen. So to attack the pathogen here, we did we studied the biology of this fungi. We know this fungi, the Aspergillus flavus, for instance, in the soil lives in 2 forms, S and L. S means produces small sclerotia, and L large sclerotia. You can see in this picture a picture of the L form, L strain. And from this, we know that the Aspergillus parasiticus, all the strains of Aspergillus parasiticus are toxogenic. And in Aspergillus flavus, the S strain, most of them are toxogenic. And in the L strain, we have about 50-50. Some will produce toxin and some will not. We selected, well, in Arizona, we selected a strain, L strain, the F36, that does not produce aflatoxins. And a few years later, we found that the same strain occurs in our orchard. And this is what we select and we use as a biopesticide, as biocontrol agent to control the Aspergillus flavus and reduce aflatoxins in the orchards. We took about 10 years of research. It took about 10 years of research to get this product registered, initially on pistachios, and with one application in the soil, and the rate is 10 pounds per acre. Now, how does this work? This is an orchard that is not treated, has the green, which is the atoxogenic strains, and the red, the toxogenic strains. When this will produce spores, the spores will move around and will produce the aflatoxin on the crop. But if you have a treated orchard where we apply the F36 in addition to the native atoxogenic strains, we increase now the atoxogenic population, and that reduces the risk for aflatoxin contamination by displacing the toxogenic strain population in the orchards. So once these results were shown and we got registration of F36 in pistachios in 2012, we started studies. Your industry asked us to perform studies in order to get this product registered for almonds. We started this research with a replicated block where we treated almonds in microplots, and also we have untreated, and we collected soils to see displacement of the toxogenic strains, and also almond samples to analyze for aflatoxin. The almond samples, of course, there were a few samples from this replicated block. We didn't see any aflatoxin in any of the samples, treated and not treated, but we saw a major difference, this major displacement of the toxogenic strains. The graph here shows on the left is the bar which shows the toxogenic strains from 90% were reduced down to less than 10% with applications year after year. In 2009, we did not apply the material, and you can see again the reversion of the coming back of the toxogenic strains, and then when we apply it again at the end of the right part of this figure, you can see the toxogenic strains go down again, which indicates that this material needs to be applied yearly. Now, these results from the microplots, along with co-inoculation results that we had when in the laboratory, where we inoculated almond kernels with the toxogenic Aspergillus flavus and the toxogenic Aspergillus parasiticus, and then co-inoculated with the AF36, we had a very significant reduction of B1, the aflatoxin B1, and G1, which is produced by Aspergillus parasiticus. The previous results from the field, and these results help us to register this strain for almost in 2017. Once the registration came, the Committee of the Food Quality and Safety approached us, and they wanted to do a major experiment to treat 500 acres in order to convince the growers that this technique, method that the growers can use and reduce the aflatoxin. This study was started in 2019 in 5 locations, so you can see them here. In each location, we had 100 treated acres about, and 100 non-treated acres. Soil samples were taken, and a lot of fruit nut samples. At the same time, when we started this, we had these 2 visitors from Spain, and these 2, along with Ramon, they improved the methodology, because the analysis of soils takes a very long time, because it involves a lot of Peter plates and waiting and selecting, and so it takes up to 2 months to get results from a certain number of samples. But using a molecular approach, a PCR technique, we reduce the time up to 10 days. So then, here are the first results from 2019 in the 5 locations. You can see in 3 locations, we have significant reduction of the toxogenic strains. The green bars with the red dot indicate the L strain, which includes the native toxogenic, the applied, the F36 that was applied, and also the toxogenic that it's indicated with the red dot. And the red bars indicate all the toxogenic Aspergillus flavus and Aspergillus parasiticus. In 3 locations, we had significant reduction of these toxogenic strains. If you put all the results together, you can see on the left of this graph the ratio of the Aspergillus flavus AF36 with the green bars. This is the native population. And the red bars are the toxogenic strains. Now, after the application, we can see that we have a significant increase in the population of the toxogenic and a significant decrease of the toxogenic strains. So this is exactly the same results we got for pistachios, a major displacement of the toxogenic strains. With that displacement, we reduce the aflatoxin positives by 40%, and we expect to have similar results here with the almonds. It would be nice also to have this AF36 when we harvest and we make this stockpile to move into the stockpile, because all the nuts will be on the ground. We'll get all the propagules of AF36 that are on the ground. Although we have not done these studies, this is an important study that has to be done, because once we show this, this will be an incentive of the handlers to encourage the growers to apply the F-36 because in that way we'll have the F-36 carried into the stockpiles and protecting and displacing the toxogenic in case we have conditions that are favorable for aflatoxin contamination. In the laboratory, we did a study. We showed that if we have relative humidity below 80%, we don't get any growth, we don't get any aflatoxin. So the limits that they have imposed in the stockpile, 60 to 70% relative humidity, are very safe for the reduction of aflatoxin. With this research, what we try to do is develop various tools to reduce aflatoxin, and I cannot emphasize more the sanitation, because the sanitation not only reduces the damaged nuts, but also by sanitizing, you remove the initial contamination of the navel orangeworm with Aspergillus flavus and parasiticus. We have the application, we have to apply the F-36. It is very important to apply the F-36, and this is applied in mid-May to late July. In fact, the best time we found out is the first part of July at 10 pounds per acre. And the application can be done. You can irrigate before the application or immediately after. And also do not apply herbicides after the application because the herbicides will reduce the sporulation of this material in the soil. Also, it is important to control the ants because the ants remove a lot of inoculum. We found nests of ants with inoculum, which is merely a seed of sorghum or barley now. We have a second product now registered, the Aflagard, in addition to F-36. So next year we'll have two products to be used. And so it is important to follow these steps in order to reduce the risk for aflatoxin contamination. And with this, I would like to thank the almond industry, the Committee of the Food Safety, Quality, and Food Quality and Safety Committee, and also Guanwei and team who supported this project. And we have a study now with 5,000 acres treated for 2001. And also the almond growers that really help us providing the orchards and for us, allowing us to get samples, soil samples and nut samples. And with this, I would like to thank you.
Hold your question until later.
Okay, I want to first of all say that based on the information that the researchers have just given us, I would submit this session might be one of the most important sessions at this almond conference this year just because of the potential for economic losses based on the microorganism growth that's potentially in the orchard and in the stockpiles. So the research that they have done for us has been welcome information. I mean, we've always had an idea of how much moisture is acceptable, but they've really refined it down so that we know where damage occurs now. So this research was probably done 15 years ago, somewhere in that range. And up until that time, we were dealing with USDA kernel moisture penalty levels, and we were dealing with CDFA guaranteed analysis levels on hulls. And now we have a much better idea of what moisture is acceptable for harvest, for storage, and for processing. So when the research first came out, I'm going to dumb it down a little bit now because hullers are not researchers. We're simple people. And when this research first came out, it was all based on relative humidity. Those are big words for hullers. So we had to figure out how to convert that initial information into what we use on kernel moisture and hull moisture. And the research finally came out with a chart that converted all that in an equilibrated stockpile so that we know what relates to what. But let's go on to the next slide. Anyway, armed with all the information that we've gained from the research, now we can establish specific protocols for harvesting, for receiving, for storage, and finally, how to make critical decisions when you're faced with some difficult problems. I mentioned the USDA levels and the CDFA levels. USDA discounts anything above 5% moisture in kernels, so that means any excess weight over 5% is subtracted from the received weight or the paid weight of the almonds. On almond hulls, California Department of Food and Agriculture classifies, or it actually has guaranteed analysis labels for a number of different commodities related to byproducts, including almond hulls, almond shell, almond hull and shell, damaged hulls, damaged high moisture hulls. So anything shipped to dairies over 13% hull moisture has to be labeled as damaged high moisture hulls. ABC, Almond Board, took the research and came out with their harvest guidelines, and they use 6% almond kernels and 12% hulls. 9% is the total moisture number. So the difference between the 5 and the 6% kernels and the 12 and the 13% hulls, I think if you look at the conversion chart that the researchers came out with, if you look at the relative humidity at the 52 level, then you have 5% kernel moisture, and that is the USDA level, of course. But at that level, we're seeing about 9.5% hull moisture, which is really dry. It's probably unusual for us to get hulls in that dry. So if you look at the 62% relative humidity, then the hulls are at 13%, which is the CDFA level, but the kernels are excessively high, almost 7%, so you're risking damage if you have kernels that high. But in between, the happy medium is 12% and 6%, and those are the numbers we're going forward with. Those are the 12% hulls and the 6% kernels that both the Almond Board and the researchers have come up with as safe levels for harvesting, for storage, and for processing. So how does the huller measure moisture? There's a number of meters that have been used in the industry. This is an old, on the left is an old moisture, it's called an Mcpc moisture computer made by Aquameasure company. The one unit on the right is the same machine now made by Finisensors. I wasn't paying attention. I don't know why it changed names. I don't know if they sold or just changed their name, but it's still available from a different company. But this machine had on the bottom you can see a sampling cup and a calibration block. This machine you could put almond kernels in the cup and measure the moisture there on your PC. You could put almond hulls in the cup and measure the hull moisture. That was really handy for almond hullers. Now, on the processing side, when you're grading almond kernels, USDA has strict calibration requirements for moisture meters. So on the left is the Steinlight, which is probably the industry standard for grading almonds. This will measure kernel moisture. It also measures a wide range of seeds and grains, but it does not do almond hulls. So it's not a good choice for an almond huller. On the right is the GAC 2100 made by Dickie John. This unit will also measure kernel moisture, and it will measure hull moisture if you grind the hulls down first. These are two handheld meters that can be taken to the field to measure moisture in the field. On the left is the Ag IQ unit that is made in Australia. This will measure, it will actually grind up the kernels and measure the moisture of the kernels. You can also grind up hulls and measure the moisture of the hulls. On the right is the Dickie John handheld meter. This one is also able to measure kernels and ground hulls. And it's made by Dickie John, the same company that made the GAC on the previous slide, and they will claim that these two meters will give you identical results. The fact is, none of the meters give you identical results, so we're always dealing with a little bit of difference. So the common thing with the 5 meters we just looked at is all of these meters require that you have to separate the product out first. You have to separate the hulls from the shell, from the kernels, and that takes time. So if you're a huller and you have hundreds of loads coming in a day, and you have hundreds of stockpiles that you want to monitor, it's not really practical to collect a sample from the field or from the trucks or from the stockpiles, crack them out, separate everything, grind down the hulls, measure the temperature, or measure the moisture results and record everything. Probably takes a good 30 minutes at least per sample, and probably more if you have distractions. So it's a time-consuming process and not really practical for high-volume sampling. These meters are different. They don't require any kind of separation at all. These 2 meters are actually the same thing. They're near-infrared measuring devices. The unit on the left was made by Aquameasure. The unit on the right is made by a successor company, Finisensors. On the left, you might be able to see a beam of light shining on the almonds that are passing underneath. These are in-hole almonds going through a pre-cleaner conveyor belt. So it's actually measuring the surface moisture. So what we're getting here is hull moisture in real time. So as it's passing through there, if the moisture changes, you'll see the moisture change register on the meter. This is a probe. I actually had a hand in developing this one. Aquameasure developed this one a long time ago when I asked them for a handheld probe. And the idea was to just be able to insert a probe in a stockpile, get a quick moisture reading, and go on to the next one. And they came out with a handheld probe to test it, and it was attached to this giant box that you had to lug around with you. But it worked. And they went back and went into production, but in production, they changed it to a bucket probe. So here you have to take a sample with the bucket. The bucket has a hole in the bottom, and you set it down over the probe and you read the moisture. It's still quick, but you still have to collect a sample. So it wasn't the handheld probe that I wanted. Now, I've always wanted to have a probe for almonds that will measure some level of moisture, whether it's total moisture or kernels or hulls. I didn't really care. I just wanted something that was quick and easy. I've experimented a lot with alfalfa probes, with grain probes, even with cotton module probes, and any number of temperature probes, and none of them gave satisfactory results. In fact, they are wildly different. This unit is made by the company in Australia again, the Ag IQ company, and I believe that Wilkie Industries here in California had production under contract with Ag IQ. I'm not sure about that, but I'm pretty sure. Anyway, the unique part about this meter is it's measuring relative humidity inside the stockpile in the air spaces between the almonds. And you can get temperature, you can get relative humidity, and then it will convert that relative humidity to kernel moisture, or you can switch over and get hull moisture. So you can get all 4 measurements quickly from a stockpile. You can probe right through the tarp and patch the hole when you're done and move on to the next stockpile. So I think this is the most practical thing for a huller to use if you want to keep a good monitoring program going. So now that we have moisture and the research data to deal with, now we can set some protocols for both harvesting, for storage conditions, for processing, the whole works. Hullers have always had protocols, and they not necessarily written policies. They could be just something in the back of a huller's head, but we've always had standards to try to maintain for both harvesting and processing. Of course, Bruce mentioned the hull snap test, and this is the most common way to determine whether your crop is ready for harvest. If you bend the hull and it breaks, you're ready for harvest. It's dry enough, you can store it, you can process it. If you bend the hull and it tears, you need to give Mother Nature a little bit more time to let that stuff dry out. If a grower is faced with difficult decisions, maybe his hulls aren't drying out as fast as possible and he needs a little advice, hull representatives from either the processor or from the huller are always available to go out and meet with a grower look at the conditions he's got and develop an action plan to go forward. Part of that action plan might be bringing in samples from the field. We can always bring in samples to the huller or to the processor and test them with our labs, and that sample can be brought in by the field representative or by the grower himself. Now, whenever we're harvesting, we always want to check the forecast ahead of time. You don't want to shake ahead of a rain, or you don't want to windrow ahead of a rain. If the nuts get wet, the best opportunity for them to dry out is still on the tree. If the nuts are on the ground and they get wet, the best way to dry them out is to leave them spread out and let them be exposed to as much wind and sunlight as they can get. Coordinate trucking with harvest schedule. That sounds like a no-brainer. There's no grower out there that wants to have his crew standing by waiting for harvest, waiting for trucks. But you also have to weigh the downside. If you harvest wet nuts, you risk a potential of loss from a number of areas. If you have high moisture, you could have storage losses. If you have high moisture, you could have processing damage. And of course, if it comes in too wet and the huller decides he needs to do something with it, drying costs can be extremely expensive. So before you coordinate the trucking, make sure the harvest is ready. And then we've had several events over the years where significant rainfall has fallen and the crop is wet throughout the state. And in these conditions, hullers may elect to bring their empty trailers back into the yard to prevent a flood of wet product from coming in. So that's just something they might do to protect themselves. You want to receive best quality you can. You want to protect the quality once it gets there. So the best way to maintain quality is to make sure it's dry before it comes in. Okay, we talked about not shaking or windrowing before a rain. Same thing after a rain. If you had a rain, you don't want to shake too early because the nuts are drying on the tree. That's the best place for them. Same thing with windrows. If you sweep up a wet if you sweep up wet nuts into a windrow, you might get some surface drying, but that windrow will not dry inside. Bruce had some information about the moisture differences between the top of the pile and the bottom of the pile, 2%, I believe. That was dry nuts. Those aren't rained on nuts. You have a bigger problem if you have rained on nuts, so it will not dry in a windrow. If you have them on the berm, just as Bruce mentioned, you get them out into the middle of the orchard where they have better opportunity to intercept wind and sunlight. Wet windrows. If you have wet windrows, the best thing to do is take your harvester, pick them up, and lay them down flat again. That's much better trying to dry them spread out than trying to dry them in a windrow. Conditioners. Please go buy a conditioner. You'd be the huller's best friend. When you remove the foreign material, the leaves, the twigs, the grass, the dirt, the debris, all those things interfere with drying. But the other thing the conditioner does, it gives the huller the best opportunity to preserve the inherent quality of the nuts that they receive. So that's the whole thing. You deliver quality, and we can preserve that quality for you. And again, never pile or windrow wet nuts. This is my opinion, but no drying happens in a pile. I've had a lot of experiments with trying to dry things in a pile, and none of them had been successful. Okay, once the nuts are harvested, they come into the plant, and ideally the huller will be able to sample every load coming in. That's not practical in most cases because the time it takes to analyze samples and the volume that's coming in. But if you can develop a plan to sample everything, then you avoid having maybe a green part of the field come in that contaminates the rest of the stockpile, and that can lead to condensation problems under the tarp. If you don't have the ability to sample everything, well, first of all, if you have the moisture, then you have the decision to make whether to accept it or to refuse it. So if it's dry enough, we can process it or we can stockpile it safely. If it's too wet, then our options are pretty limited. We can send it back to the field where it can be spread out and catch full sunlight. It doesn't have to go back in the orchard. It can go on a road or the south end of the orchard and catch some sunlight. But generally speaking, the huller doesn't have room to do this for the grower. Okay, we need our stockpile space for our stockpiles. We can't spread out large lots of stuff and use up all our stockpile storage area for drying. We just don't have that ability. Now the other option is we can send it to a dryer. There are peerless dryers, which are flat, false bottom trailers. They're we can blow hot air up through the nuts and dry them out. It's time consuming, it's expensive. Some hullers might have stationary drying machines. Again, they're slow and they're expensive. We might be able to process the product and send it to the processor and they can dry the kernels. That's a little more efficient, but it's still expensive. And the moisture criteria, we talked about the 6 and the 12%. That stuff is suitable for stockpiling or for processing. When it's above 6% and above 12%, it needs to be processed promptly. And if you're forced to stockpile this material, you have to have a plan to pick it up and process it promptly. 8% or more, 15% or more, these are much more difficult decisions. You have to dry them, or you have to evaluate the potential of keeping that product or returning it to the grower. And returning a load to a grower is never easy. The first load that I ever rejected never came back, okay? Okay, so if we're going to stockpile, Themis mentioned sanitation, and that's basic food safety for a food processor. If you're going to store it in the stockpile, you have to have a clean area free of debris, has to be free of rodent activity, has to be free of insect activity such as ants. But you also have to protect it from unauthorized visitors that can vandalize the pile. You have to protect the unauthorized visitors from contacting fumigated products, so there's a lot to consider there. So there's storage area preparation is really important, especially if you're going to stockpile in the field. You mentioned potential contamination from ground contact. At the huller, it's going to be in contact with the ground for a lot longer under adverse weather conditions, so you have much more potential for contamination in long-term storage. Drainage is important. Heavier grounds and more northern areas of the valley have much more rainfall, so if you have heavy ground, you really should have berms. The stockpiles should be put on high ground. The drainage should be diverted between the stockpiles and runoff. There are areas in the South Valley where the ground is much lighter. It has the better ability to absorb water, and you can have a successful stockpile on flat ground as long as that ground is graded for any excess moisture to run off. The key is that your grading has to be in line with the orientation of your stockpiles. Ideally, you're north to south, and your grading is north to south, but that's not always possible, not always practical. So if you're going to grade in any other direction, it has to be in the same direction as the orientation of your piles. And on drainage, I can talk maybe in question and answers about what happens when moisture does come in contact with those stockpiles. Tarp selection, we've talked about this already. White on black has been proven to be the ideal choice for maintaining constant temperatures and relative humidity underneath the tarp. You showed an interesting slide of stuff that was stockpiled in August, picked up in February under a clear tarp where the product came in dry in August. And after months of storage, you had significant condensation in that pile under a clear tarp. A lot of people have preferred clear tarps over the past because they can see what's going on, but that's not always a good thing. So if you have long-term storage, the ideal thing is to monitor it continuously in storage so you know what's happening underneath that tarp. If you're monitoring the moisture, you have to record the date, the moisture content, the grower, the location of the stockpile, amount of time it's been in storage. You have to keep all that record keeping because that's the best tool you have to protecting that inherent quality that we talked about that comes in with the product that you have to maintain. Aeration. I'm a little torn on aeration. I know if you take the tarps off, you can get some surface moisture drying. It's much more difficult to dry anything underneath the surface. So I don't think aeration is effective except for on the surface. But if you have condensation on the surface, it's a good idea to take the tarps off and aerate them and recover them before weather comes. And okay, once you have stockpiles, you might have hundreds. You want to know what's going on there. So ideally, you're monitoring everything on a regular schedule. If you can't monitor everything, you need to identify the concerns and make sure you focus on those. Those stockpiles have to be monitored or else you're going to run into a heap of trouble. Okay, I already mentioned measuring moisture content and how many loads and all that. Record keeping, it's just the most important tool we have. And once we identify those concerns, we have to schedule those things for processing. We can't leave them in storage if we have a concern. Record keeping again, very important. Okay, all this leads to, okay, what do we do when we have some real problems? In harvest, late in the season, late varieties, the weather, the heat's gone, the weather's coming, sometimes you're forced to pick up wet nuts. But every time you pick up wet nuts, you have to weigh the costs that are involved for potential drying costs. You could even have processing penalties if it's slow-running product. You can have enormous product loss from breakage, from smashing nuts, or from embedded shell. Embedded shell is inedible, so if you have mechanical damage on your product, that's a yield loss. That's a loss of paid weight. So that potential is huge, and then of course the quality losses in storage. If you're going to have to store those things for any period of time and they're wet, you risk the potential of microorganism growth, aflatoxin, salmonella, the whole works. If we're stockpiling wet nuts, sometimes we're forced to. Sometimes everything's coming in wet. We don't have any choices. Late in the season, if you're having to stockpile wet nuts, we have to have a plan to limit the time in the stockpile. And if you can't pick it up and process it, you might want to pick it up and re-stockpile it just to give it some air. But difficult decisions, but you have to do something. I mean, you have to do something to keep damage from occurring. And then processing wet nuts, there's another difficult decision. Sometimes you're forced to process wet nuts and you risk the mechanical damage, you risk the storage damage, you risk the loss of paid weight. So anyway, if you're still awake, I want to thank you for your attention. I know this has been riveting, but thank you very much.
Thank you for all of you to share great information with the crowd. So let's give another round of applause to our speakers. Thank you. So now let's, if you have any question, we have a microphone here. Yeah, Tom, okay.
Oh, for the pistachios, for instance, we know that about 3/4 of the industry treat, and this is because we have, the processing plants, so they give an incentive to the growers to treat. For the almonds, I do not have the percentage. Maybe one way will know about this.
We don't know, actually, we don't know. We're just starting to do a project trying to raise the, awareness of this tool for the industry member. We do have, trying to, done several years research, increase
Yes.
the cover acreage from 500 to 5,000. So we actually, since you asked about AF36, I'm going to continue to ask one more question for Siemens. I know this is a great tool, but we definitely have heard different comments. Growers have different ideas, thinking this is the aflatoxin issue related to handlers. So I know you mentioned about the pistachio industry. Do you have any other recommendation? How we can get the grower excited about this? Take away toxogenic strain. We have no concern for aflatoxin.
Well, I know the handlers, they are doing their best to, to have the right conditions for not increase mold and also aflatoxin contamination. In fact, when we did analyze, some of the last results of the 2019 samples, we did have very low levels of aflatoxin from those samples that we got even from the field. Of course, this can be related to the year also. It's very complicated. We know that if the growers use this material, will have a better chance this material to be transferred into the stockpiles, and then when we have not favorable favorable conditions for aflatoxin, at least we'll have this competing atoxogenic strains that will displace the toxogenic to produce the aflatoxin. So 3/4 of the pistachio industry is using the product. I'll encourage the almond growers to also use this product, the F36, and as of 2022, we'll have the Aflagard and a product of Syngenta as well. Once you use this, probably we'll have lower number of rapid alerts for the almond industry.
Okay, so that's great. Great suggestion. Definitely this is a new tool. It's definitely take some time for grower to adopt it. This is probably aflatoxin is the issue. We cannot rely on handlers alone to sort those out. You have heard that we have rejection from from Japan. Even the highest grade product, we still have a problem with aflatoxin. So you have a question?